Alright, good morning. How is everyone?
Doing alright, Nick. How are you doing?
I'm doing alright too, thanks. Alright, so let's talk about ODP 202, 203 and 204. I want to talk about header files. I want to get through more pseudocode. When did Zoom update? Because Zoom has been buggy as heck for me for about 36 hours now. They like kicked me out during my 101 class. I had to rejoin, and then I was in there twice and it kicked out my old version. Maybe my system knew it was going to get buggy. And Linux never gets updated anyway. It's running like some really old version of Zoom with none of the cool features. Or 2 days ago, okay. Yeah, it's weird. Alright, so announcement first. So I just posted an announcement. I'm extending the deadline on PA1 by 28 hours. So instead of being due at 8 a.m. on Friday, it's due at noon on Saturday. And this is based partially on looking at the ODPs and thinking that an extra day will help people. And hopefully that doesn't upset anybody. Hopefully nobody, stayed up all night trying to get it done last night because they thought it was due Friday. But let me know if that's an issue. But otherwise, so PA1 Saturday at noon, please. All right, let's look at ODPs. So 203, we were making this get node function, right? And the get node, the idea of this is you have your array of struct nodes. That's the memory of your system from which you're going to build your data structure. And you want to create a new node. You need to find a spot in that array where you can store that node's information. So get node is a function that will start with element 1, because 0 is a sentinel node. It'll start with element 1, move through sequentially, try to find the first entry where the valid field is 0. That tells you the node's not in use. And when you find it, you return that index. So, you have to declare your struct node. Anytime that you're going to use a struct node, it's got to be declared in that file. Get node takes an array of struct nodes, returns an integer. And so just loop from 1 through 99 and see if the valid field is 0. If it is, then that's the next available node, so return it. If you come out of that for loop and you didn't find a node where valid was 0, you're out of space, so return 0. So MYNULL is simply a symbol, right? So you're going to write code like this, if ll bracket index dot next equals 0. That's the end of the list, and you do some stuff, right? So this 0 is what we call a magic value, right? Why is it 0? Because someone decided somewhere that when you reach the end of the list, the next field is going to be set to 0. There's nothing inherent about 0 that says that's the end of the list. We could have used -15 and said, you know, when you reach the end of the list, set the next field equal to -15. It's a magic value, right, which is used as a flag. And in general, we don't want to hardwire magic values into our code. So all I'm asking you to do is somewhere make a define statement which sets MYNULL equal to that magic value, and then in here, instead of comparing to 0, compare to MYNULL. So it's just a symbolic replacement, right? When you do a number sign define, this symbol is a synonym for that symbol. So if I compare it to MYNULL, it's really comparing to 0. But if for some reason we wanted our magic number to be -15, instead of going through all my code and finding every place where I deal with the next field and compare it to 0, I just change one thing up here. I change MYNULL to -15. And why am I asking you to do that in this case? Well, you can just pretend I'm crazy or eccentric or something. And when we get to PA2, you'll see why I'm asking you to do that. So integer MYNULL equals 0 actually declares an integer. It allocates 4 bytes somewhere and it loads a 0 into that. And the scoping of that is within whatever function you made that integer statement. If you made it a global, right, then I could put it up here as a global, but we don't like globals. Define really just says anywhere that you find MYNULL, replace it with a 0. So yeah, you'd write where MYNULL where the 0 is, and it's for the compiler exactly. And we do this all the time. For example, when you call getCar, we compare the return value from that to EOF, right? So when you look at getCar, under return value, it'll return EOF when you get to the end of a file, or if an error occurs. So, so what is EOF? Right? EOF is a symbol. It's defined in standard.io.h to be -1. So, you know, when you call getCar, you could say, you know, if getCar returns -1, but why -1? What does that mean, right? Well, it's got a nice symbol here, EOF, which is short for end of file, and anybody anywhere on the planet that codes up a getCar and wants to see if it's at the end of the file will compare it to EOF. And if you're on some system where, you know, you're not allowed to use -1 because of some prohibition, right? And you have to set EOF equal to -2. Well, you define that in standard IO to be -2. You write getCar to return -2, and everything still works. Variables are a different thing, right? Variables, you start allocating memory, right? And this doesn't take any memory per se, right? It's really just saying, you know, is this thing equal to 0, which will probably, you know, engineering 270, just move this to itself and check the 0 bit in the status register. Something like that. Yeah, in fact, you do not want to define EOF in general. In C, it's already set up for you. If you define it yourself, you risk breaking things. So yeah, as long as you include standard.io.h, you've got EOF. And you've got a lot of other things, right? there's all this stuff that's like defined for you. All these things that you use when you move around a file and you try to do seeks, when you try to specify the mode in which something will be open, like read only or write only and so on. Those are all set up in other include files. Can you define any symbol like relevance words, or is it just MYNULL that is like special in some way? You can pretty much define anything. Right, I can define a symbol called printy-print, which is synonymous with printf. And if I don't like saying printf, but I like saying printy-print, I'll get a warning from my compiler, but it's Tuesday. No, I didn't get a warning. Right? So yeah, you can almost create your own language, and you know, this is done. If you were in 2.15 when I talked about parsing with C, there's this parse package I have, and it's just a bunch of define statements to basically create my own, you know, additions to the language. So, and you got to be a little careful, right? I don't think it'll let me do this. Hey, maybe it does. Yeah, so you can get into strange things. Colon X I never use. I use colon WQ. So inside VI, if you want to quit without saving anything, you just do a Q, right? And if you're using VI to check something and you haven't made any changes, do a colon Q. Don't do a colon X, because you know it's VI and it's really easy to accidentally make changes to your file. And if you do that and you quit, it will tell you your file has changed. Right? If you just colon X, it's going to write whatever changes you have. So Q quits without changing. If you really want to quit even though there's changes, exclamation mark forces it to quit. And then W lets you write without exiting. So you can write along the way in case your server connection goes away or something like that. And then WQ does both, write and quit. So it mentally for me it gives me a finer granularity than colon X, right? I can choose, do I want to save my changes? Do I want to get out of VI? Do I want to do both? That's all. Yeah, or you can live dangerously. All right, let's see. Okay, so that's MYNULL. I think we popped the stack on that. Yeah, cool. All right, so so that was get node, right? So let me make a few comments about ODP 203. I saw basically two main classes of issues people were running into. So when you assess your program, you put in the name of your source file. That all gets put into a log file, and I can look at those log files and see how people are doing. So I looked at those last night. I was seeing two main types of issues people were running into with the ODP. The biggest issue was simply correctly doing the incorrect thing, right? Correctly doing something different from what you were supposed to do. So the C code was fine, the syntax was fine, the logic was fine, but it was implementing something different from what you were supposed to implement, right? And that's really hard to debug because, you know, there's nothing wrong with your C statements, your C program is perfectly valid. You've got to go back to the assignment and ask, you know, am I doing exactly what the assignment says? And so some of the things that I saw on there, defining your struct node with the fields in a different order. Instead of data next valid, it might have been data valid next, right? Which will totally stop your code from working correctly. Checking element 0 to see if that was available. 0 is the sentinel node. We don't want to check 0 and return 0 as an available node. We want to start from 1. Similarly, we don't want to check element 100, but we do want to check element 99. But 99 is the last element in that array, so if 99 is not valid, there's no valid is valid, there's no available space, so we return our 0. So failing to go starting from 1, ending with 99. In some cases, you know, people looked until they found a spot where valid was equal to 1 instead of 0, in which case you're returning the first node in use instead of the first node that's free. Some people checked until the next field was equal to 0 or not equal to 0, right? Nothing to do with the next field. Here we were only looking at the valid field. Some people returned the data value of the first free node instead of the index of the first free node, right? So these are things that that you know, you can run this in GDB. You can you know, go to Stack Overflow. None of that is really going to help you, because the fundamental issue is, you know, oh, I was supposed to return the index of the first available node, and instead I returned the next field of the first available node, right, or something like that. Yeah, I know GDB helped you because you were in a bit of a rabbit hole for a while. Yeah. And you gotta keep things as simple as the assignment. If you do something that is, you know, more sophisticated, it can actually get you into trouble on these ODPs. Now, if you do it on a programming assignment where I'm grading it, right, that's okay. I'm going to look at that, and I'm going to look at your README and so on and so forth. But if you're doing something like, you know, assuming you're going to defrag the list, that will confuse the assessor, and it'll say, oh, something's wrong. So that was one class of issues I saw was basically not following the spec. The other class of issues were silly errors in C, right? Not conceptual issues, not issues with dealing with a linked list, right? But silly issues like doing one equal sign instead of two equal signs, right? The hardest bug in the world to find. Or you know, putting a return statement inside your for loop, right? Like if I move this return 0 right here after this, right? It's going to return the first time through the loop. It's not actually going to check elements 2 through 99. So you know, syntaxy things like, not syntaxy, but simple semantics things like that can be an issue. But not a lot of issues with, you know, what this was really about, which was, you know, manipulating the data structure, which is this array of struct nodes. People seem to be okay with that. It was these other gotchas that pop up and interfere with the perfect assessment. So that's you know, a good outcome of these ODPs is getting better at thinking about those things and going back and checking those things, and then you know, being more successful at not going down those paths in the future. Let's see, GDB helped me. Yeah, GDB is good. From the README file, I'm having difficulty tying the dots together on the ask versus what the answer is. Is there another spec that I didn't see? I'm looking in /temp for 203. So are we talking about ODP 203? So write your getNode function from PA1. So you really need to refer to PA1 and see the description of the getNode function in there to understand that this is an array of 100 struct nodes, to see what a struct node is, and to understand that 0 is a sentinel node. So that comes out of PA1. Okay, cool. All right, so let's look at ODP 204. So 204, we're going to start actually working with the linked list that's stored in our array. 203, we were just kind of barehanded manipulating the array of struct nodes, but now we're going to actually start working with the linked list that's contained in that array. So let's break this down. So we're making a function called getFirst. Takes the usual array of struct nodes, but it takes a second argument, which is a pointer to an integer. All right, and this is different. This is something that we're going to use to return additional information to the caller. When somebody calls getFirst, they can say something like, you know, integer I equals getFirst, and we can return a value that'll get loaded into I by saying return, you know, some expression. But we want to return two pieces of information. We want to return the data value of the first node, but we also want to return a flag saying was the list empty. So two pieces of information. One comes back as the data value. The other comes back as this argument that's passed in, but we pass it by reference, right? If we just called integer error, we would get the value of a variable. We could change that variable in our function. It's not going to have any effect outside the function. So we pass an address. This is just like when we use scanf, and you pass ampersand variable name, right? All right. So what does this program do? This function getFirst. It should take an array of struct nodes from PA1. So element 0 is the sentinel node, right? And the next field of element 0 tells you the index of the first node. And there's two possibilities. That next field could be equal to MYNULL, in which case your list is empty. Or that next field could be something other than MYNULL, in which case it's the index of the first node. All right, so what does our array look like? Here's LL. Here's element 0. There's a data field. There's a next field. There's a valid field. There's 100 entries in this array. The first entry is the sentinel, so there's up to 99 data nodes. And maybe down here, you know, is element 12. And so there's a few possibilities. It could be that our list is empty. So the next field of element 0 is MYNULL. So what do? We could have something like, index equals LL bracket 0 dot next. Okay, this is the index of the first node, or MYNULL if the list is empty. Alright, so that's a legit line of C code. Integer index equals LL bracket 0 dot next. And that will basically set index equal to whatever value is in here. So what do? If index is MYNULL, your list is empty. And you do what you're supposed to do for an empty list, which we'll talk about in a second. If index is not MYNULL, it is the index of our first node. So let's say this is 12, and let's say this is 42. Okay, what do we have here? The Sentinel node says the first node of the list is at index 12. At index 12, we find that first node, and it has a data value of 42. So we would want our getFirst function to return the value 42. How do we get to that 42? Well, index is the index of our first node, so I could do something like this. I could say struct node first equals LL bracket index. Right, this is after I've decided that index is not MYNULL. Well, if I do this, struct node is this structure. Sorry, first is this structure. And first dot data would be this 42. So that's the value I want to return. Now you can do this in one line if you want, but it's nice, I think, to sort of break it out into pieces. It's helpful for debugging, it's helpful for understanding what's going on. So that's the actual linked list part. That's actually starting from the Sentinel and following its pointer to the first node in the list, right? Which is the beginning of all happiness with linked lists. So let's talk about this error variable and the return value. So there's two possibilities. The first possibility is you might discover the list is empty. Okay, if the list is empty, the function should return a 0, and you should set the thing pointed to by error to a 1. And that's 2 lines of code. Star error equals 1, which says take the thing pointed to by this argument, set it equal to 1, and then return 0. The other possibility is you might find that the list is not empty. And so you do some stuff to figure out what the data value of this first node is. And let's just say we store that in a variable called data. All right. So how do we set up the return values properly? Set star error equal to 0 and return data, or whatever you called the data value. Right, so I don't want you to get tripped up on this error business, the idea of returning 2 things. There's code that will do that for you. You could return first.data if you were doing this and you said first equal to that. Absolutely. How do I check if LL bracket 0.next is pointing to MYNULL? LL bracket 0.next is the index of the first node. It's an integer. How do you check if an integer is equal to MYNULL? If LL bracket 0.next equals MYNULL. It's just a comparison. you have to define MYNULL, right? Definitely. So somewhere in the beginning of your file, do a number sign, define MYNULL 0. Outside of your function, like right after any includes that you have, set up that symbol for yourself. All right. Any other questions about this? All right. So linked together with ODP 204.0. Compile in the usual way. Assess it. Now, how do you write test code for this? Make yourself a bogus linked list, right? Make yourself a struct node array and set up some values, you know. Take element 0, set the next field to 12. Take element 12, set the data value to 42. That's all you need, right? You don't have to really monkey with the other values, the valids and things like that. Your get first is really just supposed to follow this pointer to the first data node or return a 0. So make an array like this, and then from main, you could say integer result equals get first my linked list, comma, ampersand, let me call it error variable, where you've declared an integer named error variable. And I would initialize that error variable to something bizarre to make sure that after you come back from get first, error variable is equal to either 0 or 1 and it's the right value. Because if you don't initialize it and it happens to be initialized to 0 by your compiler and you decide to run one test where there's no error and you come back and error variable is equal to 0, you don't know if your function set that to be 0 or if, you know, it didn't do anything to it at all and it was 0 because it started off as 0 before the call. So pick some bizarre value, right, and make sure it comes back as a 0 or a 1. For printf, does %d work for pointers? If you're trying to print inside here the value of error, %d will work, but %p is better. Yes, someone just got you in chat. Or you can %d star error, because star error would be an integer. And you don't necessarily need to know the value of error itself. You're really interested in the thing it's pointing to, which is star error, which is an int. But if you want to see the value of p just for education purposes, right, you can print it out with a %p. And then you get big, long, cool-looking hex number. And if it's 0, it'll actually print out null. All right. So let's talk about breaking program into pieces, putting things into separate files, and using include files. So I'll work with some code that I used in the earlier section. So this is totally bogus code. This has nothing to do with PA1, right? Any relationship or similarity is coincidental. So you know, I have standard I/O, I have a struct node, I make a type def for my node. I have a main program and I have two functions called init and print. Okay, I make an array of 20 struct nodes. I initialize it, I print it. Okay, my initialize function takes, you know, a struct node array, that's a struct node star, and it sets element I equal to I squared. Okay, goofy thing to do. And my print function simply goes through and prints in order all the elements of that array, right? This is not PA1. If you do this for your print function of PA1, you get 0 points for the print function. Okay, because the print function is supposed to follow the linked list, starting with the sentinel, follow the chain of next nodes, and so on and so forth. So this is just bogus code. But it's something I want to play around with, taking apart. Right, so I run this and it gives me, you know, the squares of my first 19 positive integers. And this works well, but you know, it's all in one file, and that can become difficult to manage. And you know, we're really trying to develop a set of functions for manipulating linked lists. Now we're also including a main program, so I can test your code easily. But the functions are kind of separate, right? Once you have a package of linked list functions, right, that's something you can, like, you know, put in your pocket and carry around and take out on the bus if you're bored and stuff like that. It really is kind of different from the main program that's driving it. So let's go overboard and break this up into totally different pieces, right? So so I'm going to make two more files, init.c and print.c. So so my init.c doesn't do any I/O, so it doesn't need standard I/O. It does need to know what a struct node is. I don't need to prototype init because, you know, we're defining the function. I don't need my main program. I don't need my print program. And I didn't need the type def because I didn't use it, but you know, I could. I'll go ahead and do it. Call this a MYNULL. Alright, so there's my init function. Here's my main function. Well, I'll come back to main in a minute. Here's my print function. So print doesn't need any of these prototypes. It doesn't need main. It doesn't need init. There's print. Let's see, I have main.h, main c, node h, node c. Yeah, that's perfect. And these functions, it's probably counterproductive to split things into too many pieces. And so definitely, you know, init, add, print, search, delete, probably all belong in one file. Get node, release node, you might put those in a separate file, but not necessarily. Alright, so here's the print function, right? So we declare what a struct node is, we make our type def, there's the code for print. Alright, what does this do to our main function? It lets us get rid of all of this. Alright, so when I'm looking at my main program, I don't have to look at the code for doing my initialization and my printing, right? I just see my main program. Now this still compiles. If I just compile main, I'll get these load warnings, right? These messages saying I've got a reference to init, but it doesn't know what init is. I've got a reference to print, but it doesn't know what print is. Because main.c, it mentions those. It says, hey, I'm going to use a function called init. Hey, I'm going to use a function called print. But when I'm compiling, I'm not telling GCC anything about those functions. So we need to give GCC the source code for those functions also. And then they'll compile, they'll link together, and we can run our program. All right, here's the thing. right? Init.c, I've got a struct node declaration, I've got a typedef declaration. Main, I've got a struct node declaration, I've got a typedef declaration, I've got prototype declarations, and so on and so forth. Every file that I have that uses a struct node needs to know what a struct node is. If I want to use this MYNULL abbreviation, I've got to have a typedef statement. If I'm going to call some of my functions like add or delete or things like that, I've got to have function prototypes for them. So the idea is, let's take all of this stuff, and instead of writing it in every single file, let's just put it in one file. So I'm going to make a file called main.h, and I'm going to put all that good stuff inside there. Alright, so you know, put some comments in the top so when you come back to this, you know what the heck's going on. And all that stuff that I typed in all of my files is now in this one file, which happens to be called main.h. Okay, what does that let me do? It lets me get rid of all of this. And instead I can just say include main.h. It lets me get rid of all of this. And instead I can just say include main.h. So my source code is a lot cleaner now. It's a lot easier for me to work with. It's not visually cluttered. And in particular, my main program is really, really trim now. Right? Because honestly, when I'm writing my main program, I don't care what a struct node looks like. Right? Chances are I'm not interested in knowing that there's a valid field and it's an integer and it's declared after the next field. Right? I just want to use those function calls. I don't really care about the details of them. So those details are kind of hidden in main.h. So yeah, angle brackets say what I really want to include is /user /include /standardIO.h. Double quotes say I want to include this file, which in this case would be, you know, /, so main.h in my current directory. Or, you know, I could say, you know, include quote /home /nick /good stuff /main.h, right? The angle brackets really just prevent you from having to constantly say /user /include. So yeah, double quote is basically relative to your current path, unless you put like a / in the beginning and make it an absolute. All right, so what have I put in here? I put in typedefs. I put in structure definition. I put in function prototypes. I might also put in, I don't use it here, I could put in my define statement. And now any program I write that includes main.h automatically has this, you know, define statement. So it still compiles, it still runs. What you don't want to put in .h files, though, is actual runnable code. Don't put in the actual body of a function. Don't put in print statements, loops, assignment statements, things like that. Those don't belong in .h files. If you don't want them in your main program, put them in a separate .c file and link them in. Is there a benefit to having the typedef statement separate from the struct statement? Yes, because it's easier for me to remember the syntax. That's the only benefit I know. So yeah, matter of preference. The other thing might be if your structure actually refers to the structure. You can't use the type def inside while you're defining it. All right, so let's see. So what's going on with this stuff? So there's this thing called a C preprocessor, right? CPP. I've got three .c files that I'm compiling and linking together. So I just say gcc-o main, main.c, init.c, print.c. They all get glommed together into an executable. But here's what actually happens, right? Main.c actually, gets turned into effectively an object. I don't think these files actually get created for you, but these are objects. And then these go through, so this is GCC, right? They're compiled into machine code type things, and then these go through the linker loader to create your executable. But there's a step that happens first, which is these things get run through what's called the C preprocessor. And the output of the C preprocessor is what GCC actually compiles into an object. So let's take a look at init. Init basically includes main.h, and then it has, a for loop inside a function called init. So if I run the C preprocessor myself on init.c, I get some comments up here, but basically the result is a structure statement, a typedef statement, a couple of function prototypes, and then the actual body of my init.c. So this is what gets passed to the C compiler and turned into an object and then eventually linked in. It looks like what I had before I started breaking it up into pieces, right? Basically, my code still looks like this. I just broke it into two different pieces. I took all of this stuff and I put it into something called main.h. And the advantage is, if I decide I want to add some new field to my structure, or I want to have a different typedef or something, now I can change it in main.h. And I don't have to go through and change it in each of my .c files. Yeah, I hear you on LD. I gotta admit, LD is one aspect of the system that I have never dug into, and I kind of made a conscious decision that, I better not go there. Linking is just, I like the idea that it's this magical process that happens somewhere, between here and Neptune, and if we live good lives, it will usually do the right thing. But I really don't know how linking works. I've written crude linkers myself, but LD does seem like magic to me. And yeah, when you get when you start seeing hexadecimal in your error messages from GCC, you're probably dealing with linking errors. So. And the collect to, and then buried down here, it actually tells you LD, which is the linker. All right, cool. So so go on with ODP 204. Keep working on PA1, 28-hour extension, remember. And tomorrow we will dig back into more pseudocode for PA1 and start getting deeper into the search, the delete, and the add functions. All right, have a good afternoon. I will see you tomorrow.